Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, and welcome to
Hello,
the
everyone.
third meeting of the C++ Digital Signal Processing and JUCE/other frameworks study group. How are you doing, Fotis? How are you doing, Cwits?
I'm great.
Hey, great. How are you?
Good, good. So I thought that today we could talk about what we made these 2 weeks, if we were able to accomplish our goals that we set last meeting. For instance, I was going to try to compute RMS for my auto mixer, and we all set different goals. So I wanted to hear from you all how you did and what else you stumbled upon. And then we can talk about some interesting things related to reverbs and spatial audio that Fotis is into. And then set some other goal for next meeting, because we want to keep pushing towards our goal of building instruments, audio effects, and so forth. So, Fotis, do you want to start us off? What did you do these 2 weeks?
Yes. Well, I studied a little bit of the book by Will Perkle, which is called Designing Audio Effects in C++. And I also tried to do a tutorial by the Audio Programmer YouTube channel, but I had some issues with Visual Studio and Producer, and so I couldn't progress.
So
I did more
coming back
reading
to
than
the
actually
book
writing
though, how are you liking it?
I think it's far more detailed than I thought it would be, because it is not just a book about designing audio plugins. It's like a mini encyclopedia of audio technology. And it's so amazing that it has the minuscule details about the basic structures of audio signals, and it's like being an Indiana Jones in that book. It's an adventure.
Yeah, I am reading it too. I skipped some parts that are not too interesting for me, like the details of some APIs, like the details of how the AAX API works for Pro Tools extensions.
Oh, yeah.
I'm not really interested in that. I probably use JUCE, which is going to abstract all of that for me. And I know that the devil is in the details. I'm not interested in the details. Most APIs are going to do more or less the same thing. So I skipped over those chapters, but I am reading all the chapters that are related to digital signal processing. And I find it interesting that the book says like designing or something like that in C++. And what I am getting from the book and from reading reviews online, it seems like people agree with this idea that the best parts of the book are not necessarily the C++ or the coding. In fact, there are some things that Will is doing in the code that people kind of frown upon. Sometimes it's outdated, sometimes it's just playing out weird and maybe even wrong. But in terms of the digital signal processing part of it, explaining the basic algorithms and giving you a high-level view of what the field looks like so that you can dive deeper into the things that you're most interested in, I find that that part of the book is amazing. And you do need some background to understand it. You do need to know like the basics of filters to understand the filters chapter, but for the level that I am, at least, where I don't know much, I know enough to be dangerous. I know sort of the keywords to look for, I think it's a perfect book. And I am particularly interested in one topic that is related to filters. And that book had the answer. I was interested in filters that don't cramp at Nyquist without resorting to oversampling, and they have some algorithms there. So that was kind of amazing. I was looking for that over and over in Google for hours, finding threads on KVR, and I couldn't find anything. And then in the book, it's just there. The equations are just there. So that was amazing. So yeah, I am really liking the book. And you read the chapter on reverbs, am I right?
Yes. And I saw the various kinds of reverbs, such as convolution reverb, and it has a detailed analysis on all the ways you can capture an impulse response from a room, from the traditional methods of doing a sine sweep or white noise, or using a hand clap or a balloon to capture the reverberation of the room. And then the chapter goes to algorithmic reverbs, and he breaks them down to what filters they use internally. Some of them are using comb filters, and some of them are using all-pass filters. And there is a great freeware plugin by Infected Mushroom called Wider, which is applying a specific technique of comb filtering to create the illusion of stereo widening, even in mono sources. So when you combine that with a reverb algorithm, there is like the galactic reverb by Air Windows. You can adjust how the reverb works and the all-pass filter, and you can switch between the two. Oh wait, I'm confusing it with another one. But yeah, my point is that if you are using a reverb without any filtering, such as comb or yes, that's the one.
Yeah, so I just wanted to check if I had the right one. So this is their website for this Wider plugin, and it seems to be a collaboration with Infected Mushroom, says over here. And so this is the plugin you're talking about, right? And so they are using all-pass filters to widen the stereo image, right?
Yeah, I think it's comb, not all-pass.
Oh, it's comb filtering? Okay.
Yeah.
Because I thought that maybe they were using a technique similar. So, you know, there is this video by Dan Worrell saying that headphones are not really stereo, they are binaural, and he uses an all-pass filter to, well, change left and right channels so that it gives you an impression of not necessarily wider, but just different. But that's not what this is about at all. It's using comb filters.
Yeah.
And
it's unlike any other stereo widening plugin I've ever heard. It has a specific sound. It can sound a little bit phasey if you take it too far. So it gives a nicer result when you're using medium values and multiple instances than one instance cranked up. Thank you, Andrew Huang, for that. Now, why am I saying this is because without a kind of filtering like all-pass or comb, a reverb can get pretty boring. You hear is the duplication of sound fading over time, very fast delays. So those algorithms that have filters such as the Xenoverb by Audio Thing, I think that was the company, Xenoverb.
But so coming back to Wider for a moment, it is free, but is it like open source? Can we peek under the hood and understand how these computers are working?
No, unfortunately, I don't think it is.
And do you have any insight on how they're using? Because all-pass filters and comb filters are pretty much like the basic blocks of most reverb algorithmic reverb algorithms and schemas. But again, the devil is in the details, is how you use these building blocks. So they just said that they're using comb filters. And to me, that sounds like saying we are using samples. Because it's like, sure, you are, but how?
I had an idea. There is a way to find that, but it will be very difficult. There is a script for Reaper. I think it's in Repack. Yeah. And it's it allows you to create an impulse response out of the plugin chain. So it generates an impulse response, and it's applying the VST or AU that you have in your channel in Reaper. So if you could measure the impulse response that comes from wider with the untouched one, maybe you could have some insight on how it's doing it.
Interesting. Do you know the name of this plugin that you're talking about in Repack?
Yeah, 1 second, please. I'm gonna run Reaper.
Okay.
So I can tell you the name.
Because that could be useful for other
things.
things.
Type in the search. Yeah, can you type create impulse?
No, it's not there.
Okay, 1 second. I'm going to check myself. Show action list. Create.
Oh, so it's not an effect, it's an action.
It's a Lua script. It's an action, yeah. It's by Amalgama.
Okay. Create impulse response on the effects chain of selected track. So this is going to send audio to that channel?
No, it's going to give you a pop-up box.
Oh. Okay. I need to install some other dependencies.
Oh yeah, I did install that thing. Yeah, it's one of those set it and forget it things. It's because it needs to draw the GUI for this Lua. It gives you a little window where you can choose whether to load the impulse in your instrument, or you can tell it to create an instance of reverb and load that impulse that you created inside it, so you can actually play with it.
Interesting. So there is something kind of related to this, which I use all the time. And it's this plugin.
Oh yeah, I love that. I love that thing.
Yeah.
This thing is amazing.
Yeah, you can see over here that it's sending impulses. And if I put an oscilloscope on the track, it's sort of similar in principle in that it's just sending an impulse train. And then you just put another
like a machine gun.
Yeah, if you listen to that, it sounds like a bunch of clicks. But the cool thing about this is that if you have any sort of plugin that you want to see what the curve looks like, so for instance, let's say you can put Sleek EQ here in the middle, and this doesn't have, at least I don't think it has, not on the free version anyway, maybe on the Gentleman's version, but on this version, you cannot see the spectrum, but you can see the effect that it's having by playing around with the parameters here and looking at the curve over there. And the principle of operation is this is sending clicks, this is affecting the audio, this is plotting the impulse response on the frequency domain. And it seems like the thing you are talking about is a generalization of this that works not only for EQs, but also works for any other kind of processing that would happen with any other kind of linear process, that is, right?
Exactly, and the very neat thing about this curve analyzer by Bertram is that it can show you whether a plugin is doing something even if you have set it to 0%. For example, I got a free plugin once that's called Heaviosity Punish Light. It was free on Plugin Boutique. And it has only one knob that goes from 0 to 100. And it's a kind of saturation / distortion effect. It's great for metal or epic music, I guess. Anyway, the thing is that I turned the knob all the way to 0%. And then I loaded it into Bertram EQ Curve Analyzer. And I said that it was still doing something to the audio. There are some filters that you can't really bypass even if you have set it to 0.
Yeah.
And it was interesting. It's probably a feature, not a bug, but still it was nice to see that how it functions under the hood.
Yeah, I suppose that if it's trying to emulate some piece of gear, if you run audio through hardware, you're going to get some sonic result. Maybe some sort of saturation, maybe some sort of attenuation of some frequencies because of the digital to analog converter and then the analog to digital converter on the other side. So whatever the reason may be, yeah, makes a lot of sense that if it's trying to mimic the workflow of hardware, or even if it's not doing that, if it's a design decision of something purely digital, it does make sense that it's going to change the audio even if it looks like it shouldn't. Maybe like if this gain is at 0, it could still be doing something.
Yeah, and then in fact, Dan Worrell made a video about this in his review of Brainworks console. I think it was its name. It was a channel strip plugin by Brainworks, and he realized that you can't do a null test with this plugin. You can't phase invert and hear the differences because it has its own analog emulating technology that actually affects the timing a bit. So because it's trying to be so close to analog that it has all kinds of imperfections.
Yeah, sure. So how would you use something like what you described or this? So either the Locasena script that we looked at or this, or even loading an impulse response in Reverb. How would you use these tools to make sense of what Wider is doing in terms of the comb filters?
Because when you apply a comb filter to a waveform, I think there is something specific to the spectrogram. Maybe I'm talking bull right now, but I think there was a way to identify comb filtering. Like, is it doing some sort of separation between, very fast separation between frequencies? Maybe there is a chapter about that in Will Berkeley's book.
Yeah, I do think that he covers that. He covers comb filters. He even covers this other structure that is like the inverted comb filter, where the teeth of the comb are pointing the other way. They're pointing down. But yeah, I guess if they have like one comb filter, we could probably see it over here, for instance. But if they have a network of comb filters connected in interesting and different ways, and maybe even some non-linearities on the way or whatever, it would be very hard for, I think, to make sense of what's going on under the hood.
Yeah, you're right. But I'm in fact, I have this chapter open about using 4 comb filters in parallel. But yeah, this is a very good question, and I don't know how to answer it precisely. But yeah, I think I just imposed a problem.
Interesting. So before I continue on this, I want to hear from Cwits. Cwits, how are you doing? What kind of progress have you made this week?
I made what I wanted to make. Especially, past 2 weeks ago, I decided to draw a waveform on the push display, and I was successfully made it, so I can play with it and look what audio looks like. I can zoom in, zoom out, and do some fancy stuff like add a little bit gain or decrease. So yeah, it's look like interesting. Maybe next time I can show you how it looks like.
Yeah, I would love that. So can you tell us more about how that works? I mean, what takes to draw a waveform on the device? I mean, what do you have to do your own circular buffer? Do you have to do your own drawing primitives, or do you just have something that you can say, here is a sample, please plot it?
I got from GitHub a library that works with push.
Oh.
I'm not writing it by myself, but still I have to modify it a little bit for my purposes and somewhere rewrite code for okay. But yes, this library got some basic stuff to work with push, and everything more complex I have to implement by myself. So it got one whole pixel buffer, which is sized, which is in dimensions of the display size. I hope I tell it correctly. Yes.
Could you please post the link to the GitHub library about push in the chat?
Yes, of course.
Yeah.
But one second, I have to find.
I think I have like 1,020 repositories starred on my GitHub. I'm basically following so many projects.
Where is the chat? Oh, here it is. And yes,
Lameness.
This one works for me.
What did you have to change about it? You said that there were some things that you adapted to your use. So what did you change?
For now, not much, but I don't like the way how it works with pads, because when I press pad, this library shows me the coordinates of pad, but I, for example, want to have the MIDI node of the pad.
I see. So it's not necessarily that you're changing anything about the drawing of the waveforms. You're just changing about the API, the ergonomics of using the library.
Yeah, yes, of course. But about waveform, there is in this library there is no API for drawing waveform. It allows you only draw separate pixels on the display, and then other things I have to implement by myself. And the basics of the drawing waveform is that your audio file is basically larger than the display, yes, and you have to calculate the aspect ratio.
Oh, yeah, aspect ratio.
Maybe I can try to share display.
Yeah, if you want to, you can share your screen on Skype.
How to do this? I don't know.
It depends on how you're accessing this, but for me, it's on the lower right, below our faces on the right, there is a share screen button. Depending on your device, it may look different.
Yes, I found. I think.
Yeah, so the screen sharing is working, but please bear with me because I have to put it on the screen. So yeah, it's on the screen now. And there is a weird glitch on the upper left. There is like a gray rectangle, but
because this is Skype. Where is?
Oh, okay. Well, in that case, everything is working. So you can share. You can share what the code looks like.
It's a feature, not a bug.
So yeah, I have to got the whole size of the file. Here I get the size and the number of channels. Then to calculate ratio, I have to divide size of the file by the display width. For push, it's 960, and then to multiply. Yes, and then multiply by channels. This is for my experience experimenting with Zoom. But yeah, when I got the aspect ratio, I can build pics for 1 pixel. So we have here for loop where we calculating offset of current offset of the in the audio file, yes, and for every pixel we have to calculate maximum and minimum of the peak within the aspect ratio. I don't know, sample count.
Yeah.
So if I remember correctly, for current file, which is loaded, aspect ratio was 900 with something. So for 1 pixel of the display, I got 900 samples of the audio file. So I'm getting the maximum and minimum for current pixel, and then just draw them both on the display. And I think it's...
Yeah,
yes.
I don't know if you followed my streams recently, but I guess Friday last week and Monday this week, I was writing code that is very similar to what you have on the screen, except that it was in JS effects. So I do have questions about this. The first is, how do you deal with aspect ratios that are not integers, or that, like, if you have to, for 1 pixel of the display, you have to deal with 113.75 samples. You know what I mean? You have to collect fractional samples. How do you deal with that?
For now, as you can see, the aspect ratio is calculated in double, yes, but then I using it like a basic int, like a basic integer. And I think it's a good question, but I think it's not so. Wait a second, have to use translator. Sorry. It's not so necessarily to do, because I don't want to build the exact representation of the WAV file.
Yeah, so I guess I have another question that is kind of related to this, which is, do you have to store somehow, I guess in D max and D min, I guess that's where you store this, the samples from the past. Okay, so it's not D max and D min, because that's just for the number of channels. But somewhere you have to store samples from the past, because you will want to display them in the future as they move along in time. So my question is, do you store all the samples, or do you collect just enough of the maximums and minimums of the samples to be able to display them?
No, I'm not storing them. As you can see, the whole logic is starting here. This is loop for each pixel. I'm iterating through each pixel and drawing I'm getting the raw from the audio file, raw data. And then this
okay, so
is,
SMP probably stands for sample, and that's let's say an array that has all the samples from the past.
Yes, here it is, my representation of sample. Here I got the raw audio data in the float data type.
I get it. So for every time that you want to draw, in other words, every time, probably like 30 times a second, 60 times a second, this function that you're showing us, or this method that you're showing us, is called to draw. And every time you want to draw, you iterate over the whole sample block again, just to collect the maximum and the minimum to do the drawing. And you keep doing that over and over as time passes, right?
Yes.
Okay.
For now, it's work like this, yes.
Yeah, that's how it always starts.
Maybe it will Maybe it will change in the future, I hope. I started to think that I have to calculate separate, to make separate file where the audio peaks will be already built, that I don't have to calculate this one every time, every iteration of the function, this function. Because of course it's take a little bit of the CPU power.
And the thing that you are drawing, this waveform that you're drawing, is it the real-time audio coming through a track, or is it like a sample? You just want to display a file loaded from disk?
For now, it's the sample, the file from disk, not the real-time data.
Okay, so that's something that you can do just once if you want. Unless you are like zooming into the waveform or something, you do have the entire waveform to work with. That's why you can just go fetch the raw data for the sample, because it's like a whole chunk of pre-computed audio.
Yes, I think that if it was like a real-time data, from a microphone or something like that, or a guitar, if it was analog data converted to the digital, then I have to store somewhere the representation of it to draw it correctly in the future.
Okay.
I think I don't know, because I'm not very good in programming.
Well, but you are. You made a lot of progress.
Yes. Also, I have made some basics audio plugins, like a delay. Okay, I'm not made. I just take this code from GitHub and paste in my the whole thing what I'm making. But
so how would this delay work exactly? Do you run push into Ableton and it creates a delay from the hardware of push?
No, I'm not using Ableton for this one. I'm using I have Raspberry Pi, to which is connected push, and the Raspberry is doing all the thing, like drawing to display, work with pads here in the bottom.
So that's interesting. When you have like the delay that you're showing us right now, it is not running in the push, and not even the drawing thing that you just showed, the simple player CPP file. That's also running on the Raspberry Pi, and it's just driving the Ableton push.
Yes. The push itself is only controller.
Yeah. Oh, nice. It's like you're creating your own version of Ableton Link.
And the lib push that you are using, I guess, is responsible for this bridge. It's giving you the method to communicate with the push.
Yes, of course.
Yeah, and you said before that most things work over MIDI on the push. I think you said that last meeting. And I don't think that the drawing works over MIDI, does it? I think it's like something else for the drawing of the waveform.
Drawing for display works with the system exclusive MIDI messages.
So it is over MIDI. Amazing.
It's a kind of data that runs over MIDI. It was being used in old synthesizers. It's in files that have the extension SYX.
Maybe.
And there are some MIDI files that I have found online that have a separate channel which doesn't have notes but has CSX information.
Yeah, I get it. So I guess the purpose of this lib push library is to give you a high-level API to work with, but
Yes,
it's essentially
like
just a
as
translator between what you want to do and the system exclusive messages that it needs to send down on the wire, right?
But in this library, the C6 messages is used more for the no, hard word, millisecond. How to say? This one, C6 work for the some commands. For example, for the main part of data for the drawing display and push is transferred with this lib USB. It's not the whole, for example, it's not the whole waveform is transferred through the C6 messages. It is transferred via lib USB.
That makes more sense to me.
Because C6 can't handle so much data, and it's not so fast.
So is this a library inside a library? Lib-USB inside of libpush?
I don't know really. I think libUSB is the basic library of the Linux kernel, something like this. I don't know really. And you can use it. Also in Windows you can use it, I suppose. Maybe.
Looks like a great project. Great help.
This one, yes, I like how it is written.
So yeah, coming back to the delay, I see that you have been busy. There is a delay. There is a simple filter.
Yes. Oh yes. Okay. I have implement. Oh, that's more correct word. I have implement couple of effects. Yes, the delay filter and simple player, which just take audio file and plays like music that I can hear something out of my Raspberry. And
just like FFmpeg has FFplay.
Yes. And the next step for me will be I want to figure out how to properly connect them between themselves, how to make proper routing of the audio in them. And it is a little hard for me now, I think.
And just to be 100% clear, there is no audio going to or coming from the push. It is all the digital signal processing in the Raspberry Pi.
Yes, of course. Yes.
Mm-hmm.
Yes. Because push can't handle digital audio processing.
Yeah, it's a controller.
I think it can do it if it was designed a little bit differently, but...
And can you talk to us about the delay and the basic filter?
To be honest, I stole this code from the internet. Not stole it, it is open source. I can send a couple of links for you if you're interested.
Yeah.
Sure.
I found one site called musicdsp.org.
Oh.
1 second. Chat. I took this filter.
Mm-hmm.
And there is also other examples of the filters, of the synthesizers, of the effects worth to watch, to look, to study, but not all written in the C++. So,
and it is very short amount of very few lines of code here, so that's good.
Yeah.
For me, the main idea for now is to make the base the how to say it. A second, sorry. To make the foundation where I can play with the digital sound processing, like a JUCE framework, but I want to do it myself. Yes, I don't know why. I don't know why. Like I don't want to use other things like a JUCE, like
Oh,
others.
I
I
think
think
it's
Skype cannot show some specific windows.
yeah. Skype is only showing us Visual Studio Code.
Yeah, yes, of course.
Yeah.
That's the main idea.
It's the same thing with Discord. You can do that.
I don't know really what I can tell about the filters and about filter and the delay. Maybe you have some specific questions, but I don't know if I can
I do have a
answer
question that
them
is specific, which
correctly.
is you got this code from Music DSP, which is, by the way, is a source that many people refer to when they need like a specific task. They need a particular filter or any algorithm in particular. It's a place where great things are found. And then you had this code that does something like a delay, but then you have to kind of connect that piece of code that is doing the logic of a delay to the external world. And I guess that's the part that you still have not done, right? The part where you get samples from somewhere, put it in the delay, then get the samples out and play them back into, I guess, the headphone jack of the Raspberry Pi.
Yes, and this part of code I'm trying to write by myself using some maybe examples like Qtractor on the GitHub is the open source DAW. Like
Qtractor. Yeah.
LMMS is another one. Also, LMMS is more like Fruity Loops, I suppose. Yes, but
Qtractor has a top-down interface like OpenMPT.
I was thought about using it with my Raspberry Pi, but I have only 7-inch display for it, and it's little bit small for that type of interfaces. I need little bit different interface, so it will be in the future also. But yeah, I'm trying to code my own audio engine, which one connecting these modules together, which one can add to create modules. Yes, simple player, delay, filter, and blah blah blah, which connect them and run them for processing audio. Small piece of code. Also, I got mixer. Yes. With which one makes everything together and push to the audio jack output.
Amazing. And you wrote all of this that you're showing us, all this SPI audio engine?
Yes, mostly.
You have been busy.
Mostly. Nice. I'm rewriting this code for, I don't know, for maybe third time.
Okay.
And this one's still the prototype of I don't know. I suppose I have to do this for 3 or 4 times more. Yes.
Right, and it seems like
yes.
Judging by the jack port and blah 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 that I see in your code, it is using jack, which is like the thing that actually is the driver that is talking to the hardware, right?
Yes. In Linux, there is a couple of drivers for audio. One is the jack, No, sorry. The basic is also on top of what is built everything. And the jack, the port, audio, there is another one. There is a couple more of them, but I decided to use jack. I don't know why, maybe because it is a little bit easier.
And I suppose that they all have sort of, in spirit, they perform the same tasks as the things that we are looking into in plugins. So some kind of buffer that you get a pointer to, and then some other kind of buffer that you have to write into, and some way of declaring. Well, I guess in your case, it doesn't really make sense to talk about latency, but some way of getting the sample rate, some way of getting the number of channels, and then everything else, I think, is gravy, right? These are the basics.
Yes, yes. For example, I'm using jack. I'm creating the client and the server for audio, which one have default settings. Maybe I can change them here somehow. I don't know for now. But yes, here I get sample rate and buffer size. Oops, sorry. And the main work with jack is handled in this function called process. I don't know why. I'm getting the buffers from jack and just getting buffers from my mixers and copying them out, and then I hear something on my Raspberry audio output.
Oh, so that is already working.
Yes, of course. This one works good, I suppose.
Okay, so I guess I don't really understand what you're missing. You already have something that displays the waveform. You have some audio effects like delay. So you have the simple player, you have delay, you have the audio engine, you're able to produce audio. So what you said that the next step would be to connect things, but what's missing? What do you need to connect to?
I want to make things more modular, like maybe you know there is some application called Sunvox.
Oh yeah, Sunvox.
This one, I really like it. Have played a couple times with it, and the idea of connecting those modules is, in my opinion, very interesting. I want to make something like that, but I want to make them yes, my English is not very good.
It's perfect.
Yeah.
I have to think about words, and it's not so easy.
Words are hard.
So I don't want to send, for example, just from simple player to delay and then from delay to filter, but I want to send from simple player to couple of delays, to couple of filters, and then make this net more. Yes. Более сложное.
Right. Awesome. So anything else that you want to share in terms of progress or in terms of goals, or anything that is like you looked at the code for the delay and the basic filter and you have questions, something that you didn't understand or something that you understood but wanted to talk about?
Really, I don't know. Maybe no for now.
Okay. But at least like the basic terminology, when it says like on the Music DSP website that you shared. It says that it's a Butterworth filter, 24 dB. So is it something that makes sense to you when people say like it's a cutoff filter? It's a filter with a slope of 24 dB, and that means it's a fourth order filter. All those terms that people throw around here, even on the comments on the page that you sent.
Sorry, I think I didn't understand question.
So in the page that you shared with the algorithm for the Butterworth filter, over at Music DSP, it says that it's a 24 dB resonant low pass filter, and then people throw around terms like fourth order filter and filter stability. There are all these terms that people use, and I'm asking if you like understand all of this and you're comfortable with all this terminology, or if you have questions about all of this and you would like to dive deeper on something and talk about it.
Maybe not all of terminology is understandable for me. For example, I don't know difference between big quad filter and the other things, but for now this is not the main goal for me.
Okay.
Maybe in the future.
Sure.
Not maybe, but obviously in the future.
All right. Okay. So Faris, do you want to get back to maybe you can share your screen and we can talk about the problem that you are having with Visual Studio, right? If that's something that you want to give a try.
I will stop screen sharing. Yes.
Please give me a second to run Producer and Visual Studio 2019.
Okay. And I want to ask you this. There is a newer version of Visual Studio 2022, and you're running the 2019. Any reason why you prefer that one?
No, I found out it exists yesterday.
Okay.
And I didn't update it yet.
Okay.
I have been a bit behind, but I could install 2022 if it's a necessity. Just want to learn how to use the previous version, because
it's probably not a necessity at all.
Connection.
I mean, I suppose that most tools are going to support older versions of the compiler, and for that matter, we were talking to Justin yesterday, and he said that Reaper is still using Visual Studio Code, not Visual Studio Code, Visual Studio 2005. So it's fine.
But if it works,
I'm sharing.
Yeah.
I'm sharing my screen now. My entire screen.
Okay.
So you can see. Okay, so here is JUCE.
All right, now we can see that. Yes.
Studio. Yeah. And the guy from the audio programmer is creating a new project and basic plugin, and you can choose this exporter that takes it to Visual Studio.
Oh, so there you go. Maybe Visual Studio 2022 is not even. Oh, it's an option. It's there. Okay, so you could use 2022.
It's an option, yeah.
Oh, and
this is a project.
Looking at your screen right now, it reminds me of something that I want to ask. If you all want to share your code, you don't have to. But if you want to share your code, then send it my way, because I can put it on like all the pages that we have that we are sharing with people, for people who are interested.
Yeah, we can post it on the GitHub of the study group.
Yeah, you can do that, but if you already have your repository somewhere and you want to keep it that way, then of course you can just do that.
Yeah. So you click this button, which takes the project. This is what the guy in the tutorial did. So I'm copying his steps. And he suggested that you go with standalone first, the code for the standalone, and then go to the VST one.
Oh, what's the reason behind that?
I don't know, actually. maybe I can find the video again.
How I
yeah.
understood, there is the standalone you can compile, but for the VST you have to do.
Oh yeah, exactly. Yeah, you can compile the
more
standalone, but if you have a VST, you have to
change some
exactly
settings.
If
more.
you're using.
Oh, I watched the difference.
Yeah, you need the VST SDK to compile the plugin, but I think that is included in JUCE.
Yeah, so if you want to do a VST2, you have to bring in your own VST library. You have to download it from Steinberg, but VST3 is included in JUCE. Or I don't know if it's included in JUCE or if it downloads automatically. I don't know. I don't really care. I know that it works. I am able to build a VST3. And on a high level, how are you liking the Audio Programmer playlist?
I think it has everything I need to learn in this. I want to learn all of these things because I need to become better at sound synthesis, because I find it a bit embarrassing that I still rely on presets, and I want to become so good that I can create patches from the ground up.
Well, there is no shame in using presets as long as you get the sound you want and you get good sounds.
They can be quite inspiring.
Yeah.
Exactly, but I want to go further than that because I'm always curious about how synths have worked since the very beginning. Because I have a few manuals, and one that I wanted to talk about but I couldn't find it is the original manual of the ARP 2600 synth, which was used in Star Wars. You know, they used it to create the R2D2 beeps. And the manual is not just, it's like the Will Purple book. The manual of the synthesizer has a lot of theory on how sound synthesis works, and even a few things about audio technology in general. So it's nice that a 70s manual from a super old synth has more information inside it than a recent Korg plugin. Anyway.
Yeah, I guess that has to be the case, because back then you couldn't rely on people just Googling or finding some video of some random person on YouTube to learn how to do stuff. If you're selling a piece of gear, you have to document it very well.
Yeah, exactly. And this guy is doing the same thing, and he's using Xcode instead of Visual Studio because he's on Mac. But once he does it, he automatically clicks this plugin processor. So where is it here?
I suppose it's on the right under new project. Well, I guess for the new project shared code, it's going to be under new project. Right below JUCE modules, it says new project there, source.
Yeah.
And this is the plugin editor.
Oh, great. Maybe now I can actually use the tutorial. Thanks for this.
Because as far as I understand, I don't know a lot about this, but as far as I understand, the principle behind it is you have this piece of code that is actually doing the audio processing, handling parameters, the bulk of the work, right? And that's shared. It says shared code because it will be shared by all the targets. Like the standalone plugin will use that. The VST3 will use that. So there are different projects. I don't know if that's the right terminology that Visual Studio uses, but there is like the shared code, the core, and then sometimes you will have to write specific code for the standalone version. You will have to write specific code for the VS3, VST. So you put those in the separate, let's say, projects. And right, so it seems like now you have found the plugin editor and the processor doing the DSP and the editor being the graphical user interface. And are you able to compile this? Are you able to build this and actually load the program?
Let's try.
Because right out of the box, it was supposed to anyway to build and run.
Oh. So I can click this, I guess.
I don't know, because I don't have a lot of experience using this, but I think that build is probably a good place to go, or maybe compile, but I probably would go with build solution.
Okay. Okay, let's try it. Build started, and we see this little guy. It's doing the debug, not the release.
Yeah, so, but also it's saying that it's building the shared code, which may not be what you want. You probably want to build the standalone plugin, which uses the shared code so that you can actually interact with the thing.
Oh, yeah. Oh, yeah, I have to stop this because it's showing a lot of errors.
But you have to build shared code also.
Yeah, and also, and I suppose I said that because I suppose that if you try to build a standalone plugin, Visual Studio is going to be smart and realize that it needs to build shared code as well. But Fotis, what you see on the screen there on the logs, they are warnings. They are not errors.
Yeah, they're not errors. Yeah, you're right.
Warnings is not so bad.
And it is kind of a good warning because it's saying that there are parameters that are not being used. So it just means that, for instance, say on the plugin processor, there is a warning saying that you're not using the sample rate. Okay, but that's because you have not written code that is using the sample rate variable. As soon as you start looking at the sample rate to do any algorithm, that warning will go away. So far, so good. It seems like you are on the right track.
What is
I can build it again. You were saying Cwits?
Yes. Can you fold everything in Solution Explorer, like the share code standalone plugin and the VS3?
Oh yeah. Yeah, I can't see where the code is. Is it right here?
No. For now, building is for standalone plugin, and I can tell you how to.
Yeah, I'm trying to find the code as well.
Do you see the name of the?
This is the creator.
New project standalone plugin is in bold.
Yeah.
And it's different with the new project VST. If it's bold, it means that currently building this one.
Yeah, but I did cancel the build, so I'll do it again.
You can try, I suppose.
Yeah.
If you right-click on the new project VST3 and I don't remember what, but we can watch. Set a startup project, I suppose.
Oh, I think it's this thing right here. Well, you can build only this. Wow. Okay, great. I think we found it. So I'm canceling again, and I'm trying to build this thing instead. So I'm right-clicking on standalone plugin, go to project only, and build only this. Correct?
Not quite. I think that you do want to build the shared. So I would go with the first button on that right-click menu, on the context menu. That when you right-clicked it on standalone plugin, the first thing that appeared was build. And that was, of course, when you were not in the middle of a build like you are right now.
Oh, it failed. So yeah, I'm going here again, right? And then I'm going to click this thing.
Yeah, right-click on new project standalone plugin, and then go to build.
Right. Oh, that's okay.
Because you don't want to just build the standalone plugin. You want to build the standalone plugin as well as anything that it depends on.
Yeah, exactly. The external dependencies. So now we wait. And while we're on the subject, what was the last thing we were talking about before? Oh, yeah, about sound synthesis. But now you actually referenced something else. Oh, about the dependencies. Now it escapes me.
Okay.
But yeah, you asked me a question about the playlists. right?
Yeah, I am asking you because I know about this playlist and I know about the Audio Programmer channel. I have listened to their podcasts. I have watched some of their talks on the meetup, but I have not really watched all the videos on the playlist to get started with JUCE and everything. So I wanted to hear from you if you are liking it and what you are liking about it.
Well, I didn't. I'm going to follow everything step by step, so I didn't skim through them. But this is everything that I want to learn, like I said earlier. And I want to take this even further because there are scenes such as Dennis Noise, which are using something different than ADSR, or they're using a more complicated pattern. And there is still one thing about the structure of several scenes, like the ARP 2600 that I said earlier, which have their own internal structure, and that is what gives them their character. So these are the basic building blocks, but the way that you implement the oscillators and the LFOs is what gives each synth its character. And most people are just copying each other, so you get 10 or 20 synths that they all sound the same. And they all make the same patches over and over again. Oh, 2 builds succeeded. And I have a new project .exe. So let's see that thing. Hold on a second, please. I'm going to, sorry. Hopefully people didn't see my stuff. Anyway. Where was it? It was in new project, builds. Okay. So JUCE projects, OSC. I really love Total Commander and those non-orthodox. There is also an open source one called Double Commander, but I'm stuck with this one because I have used it too much. So, here is the shared code and the standalone plugin, and let's run it. Yes, this is Kaspersky. It feels it's suspicious because this plugin is using audio input, and I'm telling that yes, it can use my audio. And nice, it looks exactly like I expected it to work, and it's even getting my microphone. Hello. So yeah, this is the standard JUCE interface that I've seen in many plugins, and even bespoke. The VST loader is based on JUCE, and so is the one in Kush View Element and in Stagecraft Universal Plug. So you can do these things, I guess. And I think that Cabbage, which is using C-Sound, is suspiciously similar to this. Because there is a developer called Pure Magnetic, and you can get the C-Sound files from his GitHub. I'm going to link it for people who are interested.
Speaking of people who are interested, we have Bo here saying that can join today, but going to watch later. So hello, Bo from the future. And Aaron Lantertronics is here saying that we are getting into JUCE, and that is true. We are getting into JUCE, but more than that, we are getting into like C++ and the basics of digital signal processing. It's like JUCE is, at least for me, just an excuse to get into these topics, because I do want to learn how to do the lower level things in C++. And Tail is here as well.
I forgot about them. Sorry.
And Tail is here too. So hello, Tail. Great to have you here, just lurking in the background. But we are happy to have you lurking, as creepy as that sounds. So yeah.
And Cwits just posted the link in the chat, which is an 8-hour video about making a 3-band compressor audio plugin with JUCE.
Yeah, and that one I can speak to just a little bit. I haven't really watched this video, but I watched some other videos by the same person, and an impression that I got is that It is for when you sort of already know. So maybe I have no experience doing this. I haven't really watched the playlist from the audio programmer, but I think that maybe the audio programmer is a better introduction. And then maybe this
looks like
other
a
channel may be
masterclass.
a second place to go to, because I think that it's slightly more advanced. But then again, your mileage may vary. It depends on where you are at and what you want to do. But I did learn a lot from watching another video by the same person, and he was developing an EQ, I think. So yeah, great work there.
Speaking of that, it's fascinating how we spoke about Will Perkle and his book so much, and all of us forgot the most important thing, that Will Perkle has created a plugin API of his own. It's called Aspic, and those things called Rack AFX, and it has a GitHub, which is here, and I downloaded this thing. It has an installer for Mac and Windows. The weird thing is that it appears to be 32-bit only.
Yeah.
Both the installer and the plugins it makes.
I have no experience using this, actually. I haven't really downloaded the thing and used it for myself, but there are, for me, some red flags. I think that maybe if you just want to follow along with the book as closely as you can, learn about all the concepts, then that's great. Probably you want to go with that. But if you are like more interested in like learning the DSP and doing something practical, I don't think that this may be the best option, because it doesn't seem to be adopted by many people in the industry. So there will be more bugs, there will be fewer tutorials, there will be more issues along the way. And it doesn't seem to be super well maintained. I mean, the last commit has been less here.
Yeah.
And it feels to me like this is more like an educational tool, because Will Perkle is an educator. So that is the impression I got, and I may be wrong. It's just something to be aware of.
Yeah, you're right, because there is another limitation of Aspic, not only the 32-bit limitation, but also the fact that it needs a specific build of the VSTG UI SDK, which is included, thankfully. But he stresses on his website that this will probably not work. I think it was stated right here. That it won't work with, maybe it won't work with other versions of the VSTG UI SDK. So there is something to think about.
Yeah. And
now,
speaking of using other APIs, I did look into iPlug 2, and that one seems very nice. It is super simple to get into. The boilerplate code that you have to write is minimal. It's much less than in JUCE. The project that you get out of the box when you start a project is like 5 lines. It's amazing. Of course, it's not as featureful as JUCE. It may not have all the targets that JUCE has. Like I don't think you can use this for all the standalone and iOS and all of those targets. I'm not sure, maybe, but that one is definitely active, and it sounds very interesting. Yeah, you can see that the last commit on this one was 2 hours ago.
And these are the targets if it has Windows 8. These are the minimum ones.
Yeah, so you can see that it's targeting a lot of. Yeah, you can do a lot with this. It can do web audio, which for me is very interesting. And getting back to the chat for a moment, Aaron says that I have some students on my retrofuturistic hardware vertically integrated project team at Georgia Tech digging into JUCE. Awesome. And Bo says that his brother is in the hospital. Oh, I wish you all the best. And
my God.
Of course, you cannot focus properly right now. That's understandable. Just hope that things get better.
Yeah, hope things get better, Bo. All best wishes to your brother. So I would like to turn off my share screen. I don't think I have anything else to share.
Okay.
So yeah. Boom.
Okay, and I already
Now
took your
my
screen off
camera should be
of the stream. If you want to, you can turn on your camera
great.
again. Oh, there you go.
I just did, yeah.
Right. So I guess with that, I want to take a minute or two to show my progress. I am doing the auto mixer in VST form. I already have an auto mixer in JS Effects, and the minimal thing that I wanted to try was just compute RMS. That's like the core of the auto mixer algorithm. So
Yeah, I remember.
it turns out that it is rather straightforward. So let me show you what I learned. Right now, hang on, there you go, and here is Fossis. There you go. So what I learned is that there is this function in the audio buffer called getRMSLevel. Isn't that convenient? So all this boilerplate around this line is what we already covered on the previous meeting. It's the boilerplate generated by JUCE when you just create a new project. And then I looked for JUCE, RMS, blah, blah, blah on Google, and I found that the buffer already has a function that does this. And I started playing around with this, and the function takes three arguments. The first is the channel. So if you have stereo, channel 0 is the left, channel 1 is the right. Then it asks for the initial sample, and then for the final sample. So you're saying, given this buffer, I want to slice it, and I want the RMS of this slice. And the RMS is just going to compute using the standard algorithm of taking the squares of all the samples, then taking the mean, so taking the, if there are 1,000 samples, square all of them, add them up, add the squares, divide by 1,000, that's the mean, then take the square root of the result. That's what RMS does. But the interesting thing for me is like this buffer, as far as I understand, the size of the buffer is not under my control. As far as I understand, I will have a host where my VST is going to load. So let's say that I'm doing that in Reaper, and over there in the Reaper settings, I will set my block size. As far as I understand, this block size that the user can select is the block size. By the way, Fossis, I don't see your camera anymore. I don't know if it turned it off on purpose.
Yeah. No, it's oh, my camera turned off by accident. I think it should be working now. Can you see me?
I do see you, but the stream does not. So it seems like we are in a strange little view here on Skype. Let me show this so that everyone can see what I am seeing. There's some trees around our faces. Yeah. I don't know what that's about. Well, we can go to an airplane. What the hell?
I think I pressed something.
Okay, that's better. And now you're back on the stream as well. So always good again.
Great.
So as far as I understand, this buffer size that the person can set on their DAW is the buffer size that you get over here. That's my understanding anyway. I may be wrong. I'll look into this some more. But what's interesting to me is that I don't want to have the RMS of, like, let's say 1,024 samples. Or if you are recording this, you may even lower this to 128 samples. So I definitely don't want my window size, the size of the RMS window, to be dependent on that setting. I want the size of my RMS to be just what I set it to, because That's actually a setting that I will want to give to the user in the existing version of the Auto Mixer. I say to the user, what is the RMS size window that you want? If you want the Auto Mixer to react faster, you want a smaller window. And if you want the Auto Mixer to be more stable, less frenetic in changing the volume of the different channels, you can set the RMS window to be bigger. And you may want to have an RMS window that is bigger than the buffer size. So my buffer size may be 1024, and I want a window of 300 milliseconds. And what is 300 milliseconds? Like if you have a sample rate of 48,000 times 300 milliseconds, is like 14,000 samples, which is much bigger than any reasonable block size anyone would use on the DAW. So I started playing with this idea of, okay, what happens if I tell the buffer to get me the RMS of a slice which is bigger than the buffer size? There is this function here, get number of samples, that is used here as well. And this is giving me the number of samples in the buffer. So in this case, I suppose this is going to be 1024. What if I ask for 1,000 more? What is that going to do? And then at that point, I stopped because I thought this was going to crash. I thought that some memory would be corrupted because you would be trying to access memory out of bounds or something like that. And as far as I know, there is not a lot of bounds checking happening in C++. That's one of the, or maybe this is something that happens in C, but in C++ the bounds checking is there. But in any case, I think that the impression I get is that in C++ people tend to take off the training wheels more in a trade-off for better performance. So that's why C++ tends to be faster than Java, because Java has all this safety in place. It's checking the bounds of everything. So I was expecting this to just crash because I would be accessing the buffer out of bounds. It did not crash.
Out of bounds, yeah.
And I learned something kind of interesting along the way. I have built the plugin. So right now, this is the only line I changed since last meeting. And I built the plugin again, and the build succeeds. And then in Reaper, I am able to create a track and load that plugin. It's called Auto Mixer. So it says here, you're a company, because I didn't fill in the metadata. But I'm able to load the plugin all right, and I have a hello world. And you can see, this is what I just compiled. It's not crashing. I can even run some audio through the thing. It doesn't crash. Now, of course, I don't really have a way of seeing the RMS. And that's one of the reasons I am kind of stuck. I could maybe fire a debugger or try to plot this somehow, or maybe there's some sort of console I can write to. I didn't really look into that. But the other interesting thing that I noticed is I wanted to see if Reaper was picking up the latest version that I compiled. So I looked at this function here, which is has editor. And right now it's saying true. The editor is the graphical user interface, the thing that is displaying hello world. So what happens if I just change this to false? Then it should not render the user interface. It should look like this, which is like, I guess, your typical Air Windows plugin. And so this is what I did. I changed this to false, and then I saved, and then I compiled again. And I was expecting, so when this finishes, I was expecting Reaper to pick this up automatically. It sort of didn't, and that was surprising to me. So the build succeeded. I'm able to see the plugin here, and I load it up, and hello world. That makes me sad. And then I tried, okay, but what if instead I come here and I say scan for new plugins? That's going to refresh something, right? Wrong. That didn't work. So for me, anyways, at least right now, it boils down to closing Reaper.
There is another option in Reaper.
Yeah, I can clear the cache.
If you go to the preferences, they clear the cache,
Yeah, but if you clear the cache, that is global. It's going to clear the cache for all my plugins, and then I will have to sit and wait for 10 minutes while all of them are scanned. So that's no way to live your life. So
horribly,
but if you close Reaper and reopen, then we have our typical Air Windows plugin. So that works.
Okay. So I wanted to talk about your question about the buffer size. I cannot answer it directly, but I think that you can find your answers in the source code of maybe a granular synthesis plugin because, or a glitch modular buffer, like, no, not modular, a glitch buffer plugin, because those things like granular, they allow you to use your own buffer, and they are repeating it to create granular synthesis or to create stutter effects.
That's a smart idea, but I think it's a heavy hammer. I probably can just dive into RMS level, go to the definition, and then I'm looking at the code from JUCE itself. And then over here, I can see how that works. And then I probably will have some questions like, what are these things? Is this a way to declare that the thing doesn't throw an exception? And what are these things? They are like asserts, but from JUCE. But then we can start to see things like, okay, there is an accumulation of a sum, there is squaring things, there is adding things together, there's taking a square root, dividing by the number of samples. So see, I can make sense of this. This is RMS. It looks like that. But the interesting thing is like, how is this accessing the data? And this doesn't seem to be doing any bounce checking. But this number of samples was something that I gave, right? And as far as I can tell, there is this check for J assertion.
I'm having connection problems.
That is checking that it's in bounds, but this is, again, I would expect an assert to crash the program when the assertion doesn't pass. The assertion is probably not passing, but still the program isn't crashing. So it's interesting stuff, but I guess the problem here is this function that comes with JUCE is not capable necessarily of taking the RMS of an arbitrary window size. So I suppose that this is going to be a theme moving forward. JUCE provides me some basic digital signal processing algorithms. It comes with something that computes RMS, comes with filters, comes with delay lines, it comes with compressors. And I think that for the most part, that's the impression I'm getting, these are like basic blocks. If you need some quick and dirty solution, go use the quick and dirty solutions like the filters. They work 90% of the cases. You don't have to worry about it. But if the core of what you're doing relies on that primitive, like if you are doing an equalizer, you probably want to reach outside the box and go do your own filters. And if you, in my case, I guess RMS is kind of a big deal for me. I want to have complete control over the window size. I may want to have different ways of computing RMS, one with a rectangular window, one with an exponentially moving average that is slightly faster to compute, though less precise. So I may want to have more control, so JUCE will not cut it for me. I will have to move beyond the box. So that's the impression I'm getting. That's what I've been learning this week. So in a nutshell, that's the progress I made.
But you could do it with JSFX, right?
Well, JSFX don't really provide a lot in terms of primitives. There is no RMS, there are no filters, no nothing. So in JSFX, the only things that come in the box are FFTs, which, interestingly enough, I don't think that JUCE has FFTs. You sort of have to use FFTW or something. And then JSFX also comes with convolution. And I expect that it's going to be using something like FFTs to drive the convolution to make it faster. But in terms of digital signal processing primitives, FFTs and convolution are pretty much... Oh, and the discrete cosine transform. So they also have DCTs. Those are the three things that come in the box. With JUCE, there are more things. And you can see some of them here, but even if you want to dig deeper, there are other modules that I did not enable, but they exist. And I can add them here. And then in these modules, there are even more things like cryptography. Maybe if I want to do some copy protection, I will not want to, but and then digital signal processing, I expect that there will be more algorithms in here. But I am also thinking that for anything kind of interesting, let's say, I probably will not be using these things. Though, of course, for RMS, one thing that I can do is just take the RMS of a window which fits in the block size, and then take the RMS of the next block, and then combine the two by just doing the same thing, right? I take the square root that comes out of one block, take the square root out of the other block, and then do the same thing over, right? Just square them, add them together, take the square root of the results, and that combines well. So for this one, I think that would kind of work. But I don't think there is a point, because this is not really doing anything super optimized that it would be worth calling into this function. It's not like written in assembly or using SIMD. It's not doing anything interesting. It's just looping over some samples. So I suppose that I could do something like that too, and come up with my own sort of delay line to hold all of these. And I'm sure that JUCE comes with some delay lines, so I can use something like that. But the point here being, I will probably not want to use the thing that comes with JUCE for this particular task.
Oh yeah, I get it. I had a question about this. Do you remember the Yulin loudness meter?
Yeah, I know this one. Yeah.
Was it created in JUCE?
No,
just out of curiosity.
iPlug 2.
Oh, it was made in iPlug. Oh.
Yeah, he is one of the major supporters of iPlug, both in terms like financially, but also in terms of, I think that this person was responsible for some or maybe most of the drawing primitives in iPlug 2, because of course he was interested in doing beautiful graphics.
Yeah, the sad thing about iPlug is that it's still in pre-release state.
Yeah, only in the sense that there are not lots of users and it has not been super battle tested. So I think that iPlug 2 is in pre-release state because they are super, super careful when they say that it's in release state. It's like mature, solid, has been around for years, because there are people who use this commercially. There are people who use this for several plugins, so it should be okay.
Should we move from JUCE to iPlug?
If you want to, I like their API. I think it's so clean, but I think I personally will stick with JUCE just because I think there will be more material. Like if I want to follow along with the audio programmer on YouTube, or if I want to like ask questions on forums, the community around JUCE is just much bigger. I do want to catch up on some things on the chat before we wrap up. So Tail is saying that there are some bounce checking in the bug, so it could crash. And I think that I am, so that's good information to have. Thanks for telling that. And I think that over here in Xcode, I do have some settings that are saying that this is like in debug mode. So maybe this would be different otherwise, but I'm not even sure exactly where I should be looking for this. But yeah, I think that, was it over here? I forget. I saw something that said like, this is going to run in debug mode. So that maybe answers the kind of weird situation that I had going on. Right, so for next week, I guess I'm going to expand on this and I'm going to do my own RMS. That's my goal. I'm going to do my own RMS thing that can work with an arbitrary window size. So if my block size is 1024, I want to be able to compute the RMS of the last 14,000 samples, 300 milliseconds. And I want that to be a number that I can set. Of course, I will need a ceiling. So at most, my window size is going to be 1 second, let's say. But I want to have control over that. So I'll have to dive a little bit deeper, learn about their circular buffers or ring buffers or however they call it. And we'll see how that goes. And how about you, Cwits? What is your goal for next week? I suppose for next meeting, I suppose it's going to be to like connect the dots and actually produce sound using the controls on push.
Mostly, I think yes. Maybe to add some more sound processing modules. Like some other effects I don't know, maybe to start messing around with the push, yes, with push controls, with drawing some GUI of those modules.
Awesome.
Something like this, I suppose.
And you're moving much faster than I am, so you can make more promises than I can do. I can like promise that I will write a function that has 10 lines of code, and you're promising to like build a DAW in the meantime, which I totally admire. And how about you, Fotis? What are your goals for next meeting?
Well, the goals that I had for this meeting, which is to follow along with the JUCE tutorial from the audio programmer. Now I know what to do, and thank you guys for helping me out.
That's entirely the point
So
of
now
this study
I
group.
will follow this tutorial. Am I glitching?
A little bit, yeah. The camera looks a little bit weird. I mean, we have a frame every 2 seconds.
Yeah,
but we can hear you.
Connection problems. Okay, great. So yeah, I'm going to do the best I can with this tutorial now that I know how to follow along the steps. And I'm still brainstorming ideas about what I could create in terms of both a synthesizer and as an effect. I have some crazy ideas about the reverb, like the ones I discussed earlier, that could work in spatial audio and all other kinds.
All right. Sounds excellent. So we have been making good progress. I'm happy. Thank you, Fotis and Cwits, for being here with me and joining us on this study group. Thanks, Arya, Bo, Aaron, Tail, anyone else who may be watching this and not being active on the chat. That's fine too. And we are meeting again in 2 weeks. So, and on Tuesday, right? This Wednesday was an exception because of our conversation with Justin yesterday, which again, Fotis, you need to watch that. It was a lot of fun. He's such a nice guy. In any case, it will be on the 15th, March 15th. Does that work for you all?
Yes, of course.
All right. So I'm looking forward to seeing you here in 2 weeks for the next meeting of the C++ Digital Signal Processing JUCE /iPlug/Ableton Live or Ableton Push /clap, I suppose. Study group. Yeah, lots of slashes in this name. All right. Thanks for being here. Bye.
Goodbye.